Welcome to EDA Academy's course on Formal Verification, SVA coding. In this course, you'll dive into cutting-edge developments in formal verification, focusing on writing efficient property codes and assertions using System Verilog Assertions, SVA. Hi, I'm Peng Yu, your course instructor. With nearly 2 decades of experience in digital circuit design and verification, I've developed this course to bridge the gap between traditional simulation engineers and formal verification engineers. Gain practical insights from industry experts and elevate your verification skills to the next level. Learn to write concise and effective property code, understand the nuances of the SVA property language, and harness the power of assertions in property-based verification. After completing this course, you'll master formal verification, focusing on writing efficient property codes and assertions in SVA. You'll apply formal verification to projects, identify suitable design modules, and describe design behaviors. The course covers developing verification environments, avoiding SVA issues, and optimizing efficiency. Our course offers a comprehensive understanding of how SVA, System Verilog Assertions, enhances verification quality, improving design error controllability and observability. You'll cover various SVA technologies, enabling you to apply SVA where it provides the best return on investment. Through lectures and hands-on exercises, you'll gain practical experience in writing concise and effective property code, understanding the nuances of the SVA property language, and harnessing the power of assertions in property-based verification. The course is structured into modules, starting with an introduction to formal verification using SVA coding. You'll learn about property checking, formal property verification, and the basics of System Verilog Assertions, SVA. The course also covers coding guidelines, the use of auxiliary HDL code, and verification component (VComp) design techniques. To enroll in this course, you should have a basic understanding of digital design principles and hardware description languages, HDLs. Familiarity with SVA is recommended but not required. Prior experience in formal verification is advantageous but not necessary. With my extensive background and expertise in formal verification projects, I'm dedicated to sharing my knowledge and insights with learners at EDA Academy. I've developed a unique formal verification methodology that has been successfully deployed in leading chip companies. For an introduction to this course, you can view the course introduction and some preview videos in the course content. Anyone who has purchased lifetime access and subscribers can access the latest content for free as long as they maintain their subscription to the course, ensuring they stay abreast of the most current content. Additionally, I have developed a series of formal verification training courses on EDA Academy, starting from foundational concepts and progressing to advanced topics. Each course is crafted by industry professionals, ensuring that students receive the most up-to-date and relevant information. Enroll today in formal verification, SVA coding on EDA Academy and take your verification skills to the next level.